Welcome to our first History Tidbits on Facebook Live. This is our first time trying it. I'm Helen Alton. I'm the director of the Haines Sheldon Museum. And we are going to talk today about the oldest item in our collection, the Halobia fossil. And the Halobia fossil is it came from an area that is known as the Alexander terrain or the Alexander Archipelago. And here you can see the number of terrains that we have in Alaska and in the Haines region. So basically, the character of a place is its geology, and geologically, our area is complex. It's a messy mix of collisions, fault lines, volcanoes, and glaciers. This mishmash of geologic activity creates a rich biodiversity. Glaciers, for example, carved watersheds, leaving deep gravel deposits, building perfect spawning grounds for all 5 North American salmon species. Our abundance of natural resources sets the stage for humanity thriving here. Now, these terrains are single origin chunks of geology, and they have uniform strata and ages. Alaska is made up of 22 different terrains, and 4 are found in the Haines Borough. This is a close-up of the Alexander Archipelago. The dark purple is the archipelago, and the light purple is Galia, which was another piece that collided in to the side. And what it looks like when the tectonic plates shift and pieces of the Earth surface smash into each other, you get mountains. You get things that are subducted underneath other plates and lifting up, or plates that crumple, and we end up with this amazing landscape and view that we have here in Haines. Now, we are on the Denali Fault, and we're going to be talking about this fault line because basically anything on this side of the fault line, on the sort of southern part of the fault line, lower part of in this picture, is the Alexander terrain, and anything up above that is something else. It's another terrain. So how did this happen? Well, it all started about 350 million years ago when the world was one continent known as Pangaea. Pangaea started to break up, and there's a piece down at the southern part of Pangaea known as the Lackland Belt, and you can see it's going to the right. It's heading east, and this piece eventually, this part of the Pangaea ends up becoming Australia, but the Lackland Belt, part of it breaks off, and the star is the part that becomes us. It goes to the east, the Earth being round, it comes back, we start to see it heading east from the west side there, and as these pieces break up, and here the seas have risen and there's a lot more water, it eventually attaches to where Alaska is going to be. Now, this is a nicer view of it from, kind of looks more like a view of the Earth with the water being blue and the Earth being green. And again, the star is to the far lower right. It's heading east. This is Pangaea just starting to break up 340 million years ago. And as it's breaking up and the plates are shifting and moving apart, and this is about the time when our Halobia fossil was formed. In the Triassic Period, about 251 million years ago to 201,199 million years ago. And you can see there's this little piece in the lower left corner that has broken off from what would become Australia and is now moving towards the area that would become Alaska. And as it moves up the coast, it just keeps moving, and follow that little red dot. And at 90 million years ago, it's getting close to joining with something. And at 65 million years ago, it slams in probably right about where Seattle is, maybe Vancouver Island, and then it slides up towards Haines. So here is what it looks like. The North American continent, the big plate that's the American plate, is in orange. And as you see, when you look at Alaska, there's very little of that American continent plate that makes up Alaska. The rest of Alaska is made up of all these bits and pieces that have slammed and slid up and have become these different terrains. So the Alexander terrain is in green. There's the Chugach terrain, the Yukon-Tanana in here, the Intermontane. So all these different terrains. We don't necessarily know where all of them came from, because to figure out where something came from, you need to have some sort of record, some fossil record, and you need to be able to match it up to something else. So the fossil, this brings us back to our Halobia fossil. These are the fossils of the Upper Triassic era and Middle Triassic. The Halobia fossil has one of the longest runs in terms of time. It's the one in the center there. And the Halobia fossil ends up being an extremely relatively common fossil, but the one that we have is identified to a specific part of the world. Our fossil is just like the ones that they're finding in Southeast Australia. So this is one of the Southeast Australia Halobia fossils, and this is our Halobia fossil that was found near Chilkat Pass, north of Haines. There are different types of fossils. There are mold fossils, cast fossils, trace fossils, and true form fossils. These are the four common fossil types. And a mold fossil is basically an impression in a surface. So it's a negative image of the original item. And you can make this easily in wet sand by pressing a shell or a stone or a leaf in wet sand or dirt. You can make it by pressing in clay. I've done this with small children where I've pressed in Play-Doh, homemade Play-Doh. And this is a mold fossil, and that's what our Halobia fossil is. Cast fossils are mold fossils that then are filled with minerals, and so they are a positive image of the original item. And the stone that the fossil is made of and the stone of the substrate are different materials. And then trace fossils are the traces left by an organism. So they're like a footprint or a trail, a snake trail. True form fossils are mineralization or petrification of body parts. And in this case, you're seeing an elephantine mineralized item. But dinosaur bones are probably one of the more typical things that we see as a true form fossil. So bringing you back to our Halobia fossil, showing you the Southeastern Australia version and showing you our version. And this is, as I said, a cast fossil. Now, just to give you a little perspective on when this was made and where it came from, it's the Triassic period. Pangaea is still pretty much one lump of land, and it happened right after the Permian extinction, which wiped out 95% of life. We don't quite know why it happened, but we do know that we had a very vibrant period, and then it all was destroyed and very few things remained. So the Triassic period is when diversification began to happen again. The oceans began to diversify. It was a dry continent, Pangaea, hot summers, cold winters, and the coast had monsoons, seasonal monsoons. There's also, because of the extinction, we find that the fossil fish record is very uniform. There's few families that survived the extinction. By the mid to late Triassic, you start to see a development of stony corals and modest reef building in shallower waters. So we're starting to get some of the things that we know today. So here we are, because of the fossil being found in the Alexandrine terrain, because we were able to match it to southeastern Australian fossils, we know that we live in Australia. Paleo Australia is the Tsirku River fan, and the Klahini is our barrier, our dividing area. So basically, if you cross Wells Bridge, you are in Paleo Australia. The Tsirku is Australia, and the Klahini is the scene. And basically, the Alexander Terrain goes between the Chilkat River and Glacier Bay. So here we are again. Here are some of the big fault lines that come through. And this is one of the reasons why we have so many earthquakes in Alaska, is because we have all these little pieces of land that are just sort of stuck together, and there's fault lines between all of them. One of the things we've developed for those of you who have families at home is a Pangea flip book, which is on our website, along with some other resources for families to try, how to a fossil making resource, and we have some links to some other fabulous websites that go into more depth on these topics. The terms for this presentation are listed here: Halobia, Triassic, Permian extinction, plate tectonics, Pangea, Alexander Archipelago, terrain, the Denali Fault line, fossil, petrification, mineralization, and Paleo Australia. And I'd like to say special thanks to Pam Randalls, who graciously donated the Halobia fossil and provided information and images for this presentation. And I can't take any questions, but if you have questions, please post them. You can email me at director@sheldonmuseum.net. I didn't put that in. And thank you for attending our very first Facebook Live presentation.